Right, let's do corrections of topic 6 revision. I'm starting with number 2, which is this table here. It says use the periodic table of elements to copy and complete the following table. So for each of these compounds, you need to name or number how many of each atom in the compound and also give the name of the compound. Right, so I did the first one for you. You have your NaOH. So if you can see, there is only one sodium, so there's one sodium, one oxygen, and one hydrogen. So in the second column you just have to write how many of each there are, and to do that you're just going to look at the subscripts, which is the small numbers at the bottom. They will tell you how many of each element is in this compound. And then to name this compound, remember we said you have to use the naming rules. If there's 2 elements, then you will name the first element, and the second one it will end in "ide." If there is 3 elements and one is oxygen, it will end in "ate." If there's 3 elements and you have an OH, it will become hydroxide. So if you look at NaOH, can you see there's 3 elements, but the second 2 elements is O and H, and O and H is what we call a hydroxide. So you name the first element, which is sodium, and then when you see the OH, you just say hydroxide. So the name will just become sodium hydroxide. So hydroxides are simple. You just name the first element, and then the OH is just hydroxide. Right, let's look at MgO, right? So that we're doing the second one now, MgO. So in MgO, can you see you only have 1 magnesium and 1 oxygen. If there is no subscripts, it means the subscript is 1. So there is only 1 of each of them. And if you look here, can you see you have 2 elements in this compound. Magnesium is the first one, oxygen is the second one, so oxygen will become oxide. So the name of this will be magnesium oxide. Right, the third one is H2O. You already know H2O is water. And in H2O, can you see you have 2 for the subscript of hydrogen, which means there's 2 hydrogens and 1 oxygen. So you can either name it water, or you can use the normal rules, which is naming the first element and then the second element becomes an "ide." So it will be hydrogen oxide. Right, the fourth one is Al2S3. Can you see we have subscripts for both of these elements? So the 2 for aluminium shows you that there's 2 aluminiums. The 3 for sulfur shows you that there's 3 sulfurs. And again, there's only 2 elements in this compound, so the second element will become "ide." So this name will end in "ide." So you're going to name the first element which is aluminium, so it's aluminium, and the second one is sulfur, so sulfur will become sulfide, and the name of this compound is aluminium sulfide. Right, the next one, you have CO, and since there is no subscripts written, it means both of them is 1 each. So you have 1 carbon and 1 oxygen. Now, since you know CO, you can also have CO2. So because there's many variations of this compound with different amounts of oxygens, now you're going to have to start adding prefixes. Prefixes, remember, is the words in front of an element that tells you how much there is. If you put mono, it means 1. If you put di, it's 2. Tri is 3. Tetra is 4. So in this case, can you see we have 1 carbon and 1 oxygen. So because there's 2 elements, the name will still end in "ide, but because there's only 1 oxygen compared to the bottom one, which we'll get to just now, where there's 2 oxygen, you're going to show that there's only 1 oxygen by putting the prefix mono in front of it. So this compound will be carbon, and then to show that there's 1 oxygen, it becomes monoc, and then you have oxide, so it becomes carbon monoxide. Now if you look at the second one, you have CO2. Now the only difference between these 2 compounds is that this one has 1 more extra oxygen than this one. So you're going to have your 1 carbon and 2 oxygens this time. And since there's still only 2 elements, carbon and oxygen, it will still end in "ide. But to show that there's 2 oxygens, you're going to put a prefix of di in front of the oxide, so it becomes carbon dioxide. Right, let's look at the last one. Now the last one, we have brackets. Now anytime you have brackets, it means that whatever subscript is out of the brackets, which in this case is a 2, it means this 2 applies to everything inside of the brackets. So this 2 is for the nitrogen and it's also for the oxygen. So it applies to both of those elements. Right, so if we look at it here, you can see you have 1 calcium, and then because you have a 2 and you have the nitrogen in brackets, it means you have 2 nitrogens altogether. And then here you have 3 oxygens in brackets, and outside you have a subscript of 2. So when you have this, it means you have to take the 3 and multiply it by the 2, so it becomes 6 oxygens. So you have 6 oxygens in this compound. Now, can you see this element, this compound here? You have 3 elements. You have calcium, that's 1. Nitrogen is the second one, and oxygen is the third one. So there's 3 elements here. So because there's 3 elements, you cannot end it in "ide" because "ide" is only for 2 elements. So if there's 3 elements, and one of them is oxygen, which it is, so we have oxygen here, it means you're going to name the first 2 elements and you're going to end the second element in 8. So when you have 3 elements and one is oxygen, it ends in 8. So this you're going to name the first one, which is calcium. So there's calcium. The second element is nitrogen, but nitrogen will be changed to 8. It will end in 8. So nitrogen will become nitrate. So the name of this compound is calcium nitrate. And if you see an 8 at the end of a compound, it tells you that you have 3 elements in it and one of them is oxygen. Right, let us do number 3, which is also balancing equations again. So here I wrote it for you here. Right, so let's look at 3a. You have H2 plus O2 giving you H2O. So this is making water. Now if we look at this here, can you see that you have 2 hydrogens on this side and 2 hydrogens on this side? So it's fine. But now you have 2 oxygens on the reactant side and only 1 on the product side. So you need to make this product also have 2 oxygens, and the only way you can do that is add a coefficient of 2 in front of the water. So now that you added 2 in front of water, you have 2 oxygens on this side and 2 oxygens on this side. But this coefficient also applies to the hydrogen, which means now you change the hydrogen. So you have a 2 here and then you have a subscript 2. So to get the total hydrogen, you multiply the 2 together. So it becomes 2 times 2, which is 4. So now you have 4 hydrogens on the right hand side, and on the left hand side you only have 2. So we need to make that into a 4 also. And how do you change a 2 into a 4? You just multiply it by 2. So you're going to put a 2 coefficient in front of this hydrogen. So now you have 4 hydrogens on the left, 4 on the right, 2 oxygens on the left, 2 on the right. So the entire thing is correctly balanced. Right, let's move on to the next one. Here you have carbon plus H2 giving you CH4. So remember we said you always start with the other elements and you leave hydrogen and carbon and hydrogen and oxygen for last. So let's start with carbon. You have 1 on the left, 1 on the right, so carbon is fine. Now we're going on to hydrogen. On the left hand side you have 2 hydrogens and on the right hand side you have 4. So you need to take this one of 2 and change it into a 4. So you're going to say 2 times 2, which will give you 4. So you will put a coefficient of 2 in front of this. So 2 times 2 is 4. Here you have 4 hydrogens. So both carbon and hydrogen is balanced. Right, let's look at the last one, which is calcium carbonate plus HCl giving you calcium chloride plus CO2 plus H2O. So again, we have many elements here. We're going to start with everything and leave hydrogen and oxygen for last. So let's start with calcium. All right, so on this side we have 1 calcium, on this side 1 calcium, so that's okay. Then we're moving on to carbon. Right, so here we have 1 carbon. Right, there's the carbon there, and here we have 1 carbon in CO2, so the carbon is also fine. Then we have chlorine. On this side we have 1 chlorine, on this side we have 2 chlorines. Because there's a subscript of 2, it's showing us that there's 2 chlorines. So we need to change this chlorine into a 2 so we can balance with this chlorine. So the only way we can do that is by putting a coefficient of 2 in front of this. So now we have 2 chlorines here, 2 chlorines here, so that's fine. Right, now let's move on lastly to the hydrogen and oxygen. So let's start with hydrogen. Here you have 2 hydrogens here. Because you put the coefficient of 2 here, it means hydrogen also became 2. So there's 2 hydrogens on this side, and on the right hand side you have water, which is H2O. So there's 2 hydrogens on this side. So both sides have 2 hydrogens, so that's perfectly fine. Now let's move on to the last thing, which is oxygen. Now on the left hand side, can you see you have CaCO3? So there's 3 oxygens all together, and on this side you actually have oxygen on both products. So you have 2 oxygens from the carbon dioxide, and you also have 1 oxygen from water. So altogether you have 2 plus 1, which is 3 oxygens, and on this side you also have 3 oxygens. So automatically it's all balanced, and all you had to do is change just the coefficient of HCl.